We're going to talk about neutralization here. Neutralization occurs simply when an acid reacts with a base to produce a salt and water. And that is the simplest definition of neutralization. We're essentially taking the hydrogen ions from the acid, reacting them with hydroxide ions, and we are making water. So there's a very, very simple ionic equation. Remember, acids are acids because they have lots of hydrogen ions. Now, there's a couple of things we need to know, and if you don't know these, we can't go any further. Okay, we need to know the formula of hydrochloric acid. We need to know the formula of three common acids, three common lab acids. Hydrochloric acid, the formula is HCl. Now, when hydrochloric acid is neutralized, the hydrogen ions from the acid react with the hydroxide ions to make water. But this chloride, the chloric part is the chloride ion. The chloride ion makes a chloride salt. Okay, so the salt produced is going to contain chloride. So hydrochloric acid makes chloride. That's what we need to know. Formula of the chloride ion is Cl-. Sulfuric acid, the formula is H2SO4, must learn that. The ion that is formed in the salt is going to be the sulfate ion. So sulfuric acid makes a sulfate, and the formula of a sulfate ion is SO4 2-. That's important we know these ionic formulae because you may well have to write the correct formula of the salt. Likewise, nitric acid, formula of nitric acid HNO3. Nitric acid makes a nitrate salt, and the formula of the nitrate ion is NO3 with a single negative charge. So that is absolutely crucial. Okay, so there's four types of neutralization reactions we're going to look at. Four types of reactions where the acid produces a salt. First one, acid reacting with a metal oxide makes a salt and water. So let's look at some of these examples on the next page. So we've got acid with the metal oxide making a salt and water. So we've got hydrochloric acid reacting with magnesium oxide. Hydrochloric acid, the formula is HCl. Remember, you need to have learnt that. And it's going to react with magnesium oxide, MgO. When that happens, okay, the magnesium takes the chloride from the hydrochloric acid. So we make magnesium chloride. And the other product is going to be water, H2O. Let's write that word equation up here. Hydrochloric acid. I'm not going to do word equations for all of these. You need to do some of them on your own. Plus magnesium oxide. So the magnesium takes the chloride from the hydrochloric acid. The magnesium takes the chloride from the hydrochloric acid. So that makes magnesium chloride. Plus, never forget the plus water. Okay, lots of people write the magnesium chloride and they think themselves terribly smart because they've remembered that they've worked out the name of the salt, but then they forget the water. Okay, balancing this equation, one hydrogen there, two hydrogens there, so we're going to need two hydrochloric acids. Okay, two chlorines there, we've got two chlorines in the magnesium chloride. Okay, one magnesium, one oxygen, so just a two there balances it out. Okay, this next one, zinc oxide plus nitric acid. So the zinc is going to take the nitrate, so it's going to make zinc nitrate. I'm not going to write the reactants out here, you can write those out, plus water. Okay, so that's going to be HNO3, remember we have to learn those, plus zinc oxide. I've given you the formula of zinc oxide there. Zinc's a transition metal, so it's not obvious what the formula is. So I've given you that formula, and that makes zinc nitrate, like so, plus water, H2O. Right, balancing this out. I've got myself two nitrate ions there. Okay, so I'm going to have two nitrate ions there. Two hydrogens, that works. One oxygen, those three oxygens there are in those nitrate ions there, you see. Okay, next one. Sulfuric acid plus copper oxide. So the copper, okay, is going to take the sulfate, the from the sulfuric acid. So that's going to make copper sulfate, CuSO4 plus water. And it's the same with all these neutralizations. The zinc takes the zinc nitrate. Magnesium takes the chloric, the magnesium chloride. Here, the iron's going to take the chloric, iron chloride. Okay, every time a salt is produced, the metal from the base takes the non-metal ion from the acid that isn't the hydrogen. Okay, right, similar equations, finish this one off. Copper oxide, Cu. If it's got a 2 like that in Roman numerals, it means it's a 2 plus ion. Okay, oxygen is a 2 minus ion, so it's CuO. Plus the sulfuric acid, H2SO4. Notice I wrote those the other way around that time to how they're written in the word equation. That doesn't matter. Okay, as long as they're both on the reactant side, on the left-hand side of the arrow. Okay, so copper oxide, sulfuric acid, copper sulfate, plus, of course, water. Never forget the water. Okay, one copper, one sulfate, 2 hydrogens, 1 oxygen, that's balanced. Hydrochloric acid plus the iron oxide is going to make iron chloride. So the iron takes the chloride, iron chloride. Hydrochloric acid plus iron oxide, Fe2O3, makes iron chloride plus water. Again, you can write the reactants in, please. Plus H2O. Right. Looks like a more interesting one to balance, doesn't it? Let's see if we can do this. So 1 hydrogen there, 2 hydrogens there. So I could put a 2 in there, but I'm not going to do that just yet because this chlorine is going to be interesting, isn't it? 1 chlorine there, 3 chlorines there. Okay, so if I put a 3 there, I've got 3 hydrogens, but 3 is never going to go into 2, is it? Okay, so my gut feeling here is we're going to need this multiple, the first column multiple of 2 and 3, which is 6. So I'm going to put a 6 there. 6 hydrogens, okay? So I'm going to need 3 times 2 is 6 hydrogens there. 6 chlorines, 3 chlorines, so I'm going to need 2 of those, okay? Fe2, 2 Fe. O3, 3 oxygens, okay? Difficult one to balance. Right, I can whip through some of these others because I'm not going to do every one of these. You can do some on your own. Right, acid plus metal hydroxide. A metal hydroxide, that is an alkali. So you could say this is acid plus alkali. It makes salt plus water. Our metal hydroxide has to come from group 1 or group 2 at the periodic table. Well, most normally does. So lithium hydroxide, sodium hydroxide, potassium hydroxide. Okay, so again, same. The sodium here is going to take the chloride from the hydrochloric acid, sodium chloride. The metal here takes the non-metal that isn't hydrogen from the acid. Okay, so this is going to be HCl, hydrochloric acid, plus sodium hydroxide, NaOH, makes sodium chloride plus water. Okay, so it is going to be sodium chloride plus water. Balancing quickly, 1 chlorine, there's 2 hydrogens there, 2 hydrogens there, there's 1 oxygen there, there's 1 oxygen there. I think that looks balanced already to my mind. Next one, magnesium hydroxide, nitric acid. Magnesium from the alkali or the metal hydroxide, the magnesium takes the nitrate ion from there, magnesium nitrate. Okay, magnesium nitrate plus water. You can balance those on your own. Lithium here, from the sulfuric acid, lithium sulfate. Okay, so predicting the salt that is produced is the first thing we have to do, and then you can put balanced symbol equations together, so you can have a go at that one as well. Right, next type of neutralization reaction. So far we've had acids reacting with metal oxides. We've had acids reacting with metal hydroxides, and here we have acid reacting with metal carbonate. Produces a salt and water and carbon dioxide. So they all produce salt and water, don't they? Salt and water. So acid plus metal oxide, salt and water. Acid plus metal hydroxide, salt and water. Now the interesting one here, acid plus metal carbonate, salt and water, but this carbon, that's got to come into the products as well, and that comes into the products as carbon dioxide. So if you ever see one of these reactions, you will see it bubbling or fizzing or effervescing. It all means the same thing. It means a gas is given off. So products are produced in exactly the same way. The metal from the base is going to react with the non-metal that isn't the hydrogen from the acid. So in this case, the chloride, calcium chloride. So this makes calcium chloride. You can write the reactants in. I'm going to write the products here. Calcium chloride plus water, plus carbon dioxide. The boxes aren't really big enough, are they? plus carbon dioxide. So this time, hydrochloric acid, HCl, calcium carbonate, CaCO3. Okay, the carbonate ion, by the way, is a CO3 2 minus ion. That's why calcium's in group 2, forms 2 positive ion. That's why the formula is CaCO3. Okay, formula of calcium chloride, CaCl2, plus water, plus H2O, plus carbon dioxide, CO2. Balance this out. 1 chlorine, 2 chlorines. We're going to need 2 of those then. 2 hydrogens, 2 hydrogens. Okay, 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygens. 1 oxygen there, 2 in there, it's 3. 3 oxygens on the right hand side. That equation is balanced now. Have a quick look at this one and then I'll leave you to do the last one on your own here. Nitric acid. Okay, that's going to be HNO3 plus sodium carbonate. Remember I told you sodium carbonate ion, CO3 2 minus. Well, sodium is in group 1 of the periodic table. Okay, so let's just do that down there. That's therefore going to form 1 positive ion with a CO3 2 minus ion. So these charges aren't balanced. How do we balance them? We're going to have more positives. So we need a second sodium ion. So the formula of sodium carbonate, Na2CO3. There is a video on the writing the correct formulae of ionic compounds. If that didn't make sense to you, watch it. Okay. So it's going to make the sodium is going to take the nitrate from the nitric acid, so it's going to be sodium nitrate. So sodium nitrate is a product, and I've given you that formula. Plus carbon dioxide, because it's a carbonate, plus water, because neutralization reactions make that water. Okay, so we need to put those in there, don't we? Plus H2O, plus CO2. Right, 1 hydrogen there, 2 hydrogens there, so we need 2 of those, aren't we? Okay, can't get around that. That makes 2 nitrate ions, so we're going to need 2 nitrate ions there. Okay, so 2 sodium nitrates. So we've got 2 sodiums, 2 sodiums. We've got 1 carbon, 1 carbon. We've got 3 oxygens there. 1 on plus 2 is 3. That all now balances out. You have a go at the last one on your own. Last type of reaction where the acid is neutralised. A bit different. This time it's not salt plus water. This is salt plus hydrogen. When you take the acid and react with the metal on its own, it makes a salt and just hydrogen gas. So again, you see it's fizzing, bubbling, or effervescing. If you were just watching it, you could tell the difference by collecting the gas, lit, splint, squeaky pop. If you were to collect the gas from this one, you'd have to bubble it through lime water and you get, it goes milky. Okay, so you could identify the carbon dioxide, you can identify the hydrogen. Right, again, the salt is made in the same way. So the metal here reacts with the non-metal that isn't hydrogen from the acid, so it's going to be aluminium chloride. So the products of that one are going to be aluminium chloride plus hydrogen. Okay, aluminium, group 3 of the periodic table, reacting with hydrochloric acid. The hydrochloric acid is a single negative ion, isn't it? We've said that already. So aluminium's in group 3, Al3+. Okay, are these balanced, these charges? No, they're not. How do we balance them? We need more negative. We're going to need 2 more negatives. So I have 1, 2, 3 aluminium chlorides in the aluminium chloride. So the formula is going to be AlCl3. Okay, plus hydrogen. Right, difficult one to balance. Let's have a quick go. 1 aluminium, 1 aluminium. Okay, that works. 1 hydrogen, 2 hydrogen. So I could put a 2 there, but 2, that would make 2 chlorines. 2 and 3, never going to go into each other. So we need the first common multiple of 2 and 3, which is 6. So I'm going to put a 6 there. Okay, and I'm going to put a 2 there, because 2 times 3 is 6 chlorines. 6 hydrogens, I'm going to put a 3 there. 3 times 2 is 6 hydrogens. Horrible one to balance. And you may think it's now done, but it's not, because by putting that 2 aluminiums there, we need that 2 aluminiums there. You can have a go at the rest of those and finish those off. They are examples of the neutralization reactions you must know.